Hey, college algebra. So up to today, we've been looking at functions with single equations within them, but now we're going to be talking about piecewise functions. And piecewise functions are functions with multiple equations within them. So by the end of the video, you guys should get a good old laugh out of that. All right, so let's get started. First, let's talk about these different parent functions. And these parent functions are pretty important to understand and the reason why they look the way they do. And so if you go to your books on page 109, it'll give you a good understanding of why each looks the way it does. But anyways, these should be a fair reminder to all you guys. But the one that might not look familiar is this greatest integer one. And what this is saying is that whatever integer you're on, so like here you have 0 is your greatest integer, anything less than your next integer. So 0 is your value there. And here you'll have 1 and then 2. And so that's what it means by the greatest integer. Okay, but now let's talk about piecewise functions. And a piecewise function is defined by two or more equations. Each equation applies to a different piece of the domain of the function. So here, in this function, we have two pieces, our green one and our blue piece. So what's the equation of our green? Well, that's just going to be x plus 4. But now we have to state our domain. And so x can be anything greater than or equal to -4, or less than or equal to 0. Okay. So that's our domain equation of our green bit. Now for our blue bit, our equation is just going to be -1/2 for our slope, and our y-intercept is 2. Now our domain here, we have to be careful because there's a hole at x equals 0, so x can be anything strictly greater than 0. X can be anything strictly greater than 0, but less than or equal to 4. Okay, so now that we have our two equations, we can combine them into one general function. And so how we do this to get this piecewise function, we state our equation, and then we write our domain. All right, and now we just have to do the same thing for the second piece. So that one's going to be 0. All right, and that's our piecewise function right here. And that's what this should look like, equation, then domain. All right, so let's do some more examples. So here for this one, start by saying f of x is equal to some squiggly. And here, we're just looking at a horizontal line. And so that's just going to be y is equal to 1. So I'll write 1 down as our equation, and then comma its domain. And so its domain is anything less than or equal to 0. Okay, so that's our first one. Now let's look at our second one. That one's just going to be x is equal to 2. So here we'll write down our equation and state the domain. Now there's a hole at 0, so it's strictly greater than x, and then less than or equal to 3. Okay. Now we just have our last one. That one's going to be 3. The domain of that one is going to be anything greater than 3. Because there's a hole at 3, you can't say it's greater than or equal to. Okay, so now I'm going to pause the video and allow you guys some time to try this on your own. And I'll unpause it with the solutions, and we can compare solutions. So those are the two solutions I ended up getting. In this one, its domain is x greater than 0, because there's a hole at 0, so it's just greater than, and then it goes all the way out to infinity, so we just leave it as x is greater than 0. Okay, but what if we're looking at two pieces that aren't linear? So first, let's try to find the equations of the green one. So here, y is equal to something. And so it's supposed to be touching right there. All right, how can we figure this out? All right, so we look at where some points are. And so we'll label those points right there. Now we go to our parent functions list, and we look for some resemblance. So it looks like it could be something along x squared, right? Now if we check our points, this one right here is just going to be 1, 1, and this one's going to be 2, 4. And so, therefore, this one must be x squared. Okay, now what's its domain? Well, x could be anything less than or equal to 0. Okay, now what's the equation of our blue piece? Now it looks like it could be like a square root or a cube root, not too sure. But anyways, this guy's point is 1, 1, and this guy's point is 4, 2. And so we go over here, we can see this one is 1, 1, and this one's 4, 2. So it's just the square root of x. Okay, now what's the domain of this one? Well, this one's going to be x is greater than 0. Now, why did I say greater than 0 instead of greater than or equal to 0? Well, up here, we already stated that it's equal to 0. And so we can't have two functions equaling some point. So we decide that our second one will be greater than 0. Okay, but now we just have to put this into one general partial function, or I'm sorry, piecewise function. So if f of x is equal to squiggly, we'll have x squared, comma, less than or equal to 0, the square root of x, and x is greater than 0. All right, and so that's our piecewise function when we're looking at lines where there are lines that are not linear. Okay, but now let's flip it around. Let's do the opposite. So now given a piecewise function, let's go ahead and graph it. All right, so let's look at this first one. We have the equation y is equal to 1. All right, so that goes for our domain from anything from 0 all the way up to 4. Now we have the equation x plus 5 for anything less than 0. So if y is equal to x plus 5. So we plot our point, the y-intercept. But I hope you guys caught that. That shouldn't have been a dot. It should be a hole because it's less than, not less than or equal to. And then we just graph it. And now go on to infinity because there's any x less than 0. All right, so that's the graph for the first one. And for this one, I want you guys to try to solve this one on your own. I know this is something new because there's 3 equations in there now instead of 2, but you guys should still get the general idea. So go ahead and pause the video and unpause it with your solutions. All right, so that's what I ended up getting. And so your 0, or your y equals 0 bit, should have holes because these are both less than or greater than, nothing equal to. All right, now let's look at this example. And here we're looking at 2 equations that are nonlinear. So here we have x cubed for anything less than or equal to -1. So we go to our parent functions, look at x cubed, and here's our -1 right here. And so our function is going to be looking just like that. So then if we go back, go to -1, we can graph our x cubed. Okay, But now we're looking at x squared, and it's going to be open at the point -1, and we just graph it. Just like that. All right, now one's going to go off to infinity as well. All right, so we looked at two different cases where we have to graph the piecewise function given the piecewise function, or write the piecewise function given a graph. Now let's look at a story problem. And so instead of giving you guys a whole story, I just gave you guys a simple situation. So our f of x, or our charge, and our x is our minute. So we're given this piecewise function right here, and we're going to be asked some questions. Well, before we even look at those questions, what I like to do is figure out what this graph looks like. And so here we're going to have the equation x, or y, is equal to 50 between a domain of 0 and 600. And then we'll have this equation for any x greater than 600. And so when we put those together, we'll end up getting a graph that looks just like that one. Okay, but let's go over some questions. How much is the charge for 710 minutes of the cell phone use for 1 month? Okay, so 710 is our minutes, which is our x. So we're going to put that into our x of our piecewise function. Now, how do we decide where to put this? Are we going to put it here, or are we going to put it here? Well, the answer is, since 710 is greater than 600, it's going to be put into this one. And so we'll have that f of 710 is equal to So once you get that all figured out, you should get 474. Okay. Now the trickier bit. How many minutes? So we're trying to solve for x. Not too sure what it equals. Of service were used in 1 month, the cost, or f of x, is equal to 167. Okay. So we look at our function. I'll go ahead and erase all this. This is our y, and this is our y. And now our y, or f of x, is equal to 167. And so for this one, since this y is only equal to 50, it can't be this one. We can eliminate that. But for here, this can be any y greater than 50. So we got to choose this one. Okay. So we'll have 167 is equal to all right, and so now we just solve for x. Start off by adding 190. Okay, we just multiply by the reciprocal. It's the locus. So that's our answer. Okay, so underneath the video, there are a couple questions on the Google form that we'd like to have you guys answer. And other than that, I hope this video is helpful and that you guys have a pretty decent understanding of what a piecewise function is and what it looks like. And we'll see you guys tomorrow.